Hello and welcome to Crazy Math Productions. We're continuing our unit on quadratic equations and expressions, radical expressions. Today we're going to look at a method that's going to really help us. Right now we don't have a way to solve quadratic equations with a linear term. So this is a way that we're going to be able to break through and be able to solve quadratic equations. So let's go ahead and get started. Now earlier we had found a method for solving that I had said we're going to be able to use a little bit more later. So let's go back and review what exactly we had done. Now to solve graphically, we replaced the y with, we had put y equals 2x minus 2. We had solved um, and graphed this. We went down 2, using Moby in the boat. We rise 2, run 1. Rise 2, run 1. And then we graph our line. And what we had done is to say, you know what, let's put in a 0 there. And what is x when the y is 0? So look, when y is 0, we're here on the x-axis. Well, what is x? X equals 1. Well, algebraically, we can solve 0 equals 2x minus 2. We add 2 to both sides. 2x equals 2. Switch those sides. Divide by 2, and we get x equals 1. So we can see that they do corroborate there. Now, in this case, what we're going to do is we're going to get equals 0 and try to find that 0. We're going to replace the 0 with y and then see exactly where it hits the x-axis. And that's going to give us our solutions. Now, we can solve 2x squared equals 8 algebraically. We would divide by 2. X squared equals 4. Take the square root of both sides. We get the absolute value of x equals 2. And of course, x equals positive or negative 2. So we know what we should be looking for. Now we want to solve this graphically. To solve this graphically, first of all, we have to get this into standard form. So 2x squared equals 8. We're going to subtract 8 from both sides. 2x squared minus 8 equals 0. This is the main function that I'm dealing with. Now, I'm going to replace the 0 with a y. And now I'm going to try to graph it. Let's extend this into full standard form. X equals the opposite of b over 2a. Opposite of 0 is 0. 0 divided by 4 is still 0. And so, as we learned in our last lesson, our vertex is going to be centered at 0. And we're going to go up 1, up 2, down 1, down 2. And we're going to plug this into the simpler form, which is this one here. So plug in 2. 2 squared is 4, times 2 is 8. Plug in 1. 1 squared is 1, times 2 is 2. Plug in a 0. 0 squared is 0, times 2 is 0. And if this has gone well, we should get a 2 and an 8 here. That would complete the symmetry. Now we do need to double check to make sure. Two things could have gone wrong. First of all, my algebra, my numbers and operations here, order of operations could have been done incorrectly, or my vertex could be in the wrong spot, and that would prevent that symmetry from happening. So let's plug in negative 1 and see if we get 2. If we do, everything is good. Negative 1 times negative 1 is 1, times 2 is 2. That works. We're ready to go. Now, I have forgotten minus 8 here. So 2 on 2, 2 squared is 4, times 2 is 8. 8 minus 8 is 0. Plug in the 1. 1 squared is 1, times 2 is 2. minus 8 is negative 6. 0 squared is 0 times 2 is still 0. Minus 8 is negative 8. Negative 1 times negative 1 is 1 times 2 is 2. 2 minus 8 is negative 6. The symmetry is working. This is good, so we get a 0 as well because the symmetry is still preserved. Sorry about that. All right, now 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, negative 6. And keep in mind that there is a line of symmetry, a vertical line of symmetry. And if I count 1 over, it should be 1 on the other side. Again, 2, 0, it's 2 units to the line of symmetry there and 2 units across. And there's my graph. And you notice that the x-intercepts here are positive 2 and negative 2. So we can say x equals positive or negative 2. And you can see that these agree with each other. Again, we're going to solve algebraically. We're going to multiply with the reciprocal here. Take the square root of both sides. So we get absolute value of x equals 4. X equals positive or negative 4. So we know algebraically that's what we should have. Now, graphically, we're going to expand this. First of all, solve to get 0. Subtract 4 from both sides. I have my 0. Replace the 0 with y. Now I need to expand this into full standard form. So there's no linear term, so plus 0x. And now this is what I want to graph. So first of all, the all-important vertex. X equals the opposite of b, which is 0, over 2a, which is 1/4. Thankfully, it doesn't really matter unless this is 0, which would be undefined. 0 divided by anything besides 0 is 0. So my vertex will be centered at 0. And now I need to go back to the simplified version. And we're going to go up 1, up 2, down 1, down 2, and just see where this goes. Let's plug in 2. 2 squared is 4. A fourth of 4 is 1. Minus 4 is negative 3. Let's plug in 1. 1 squared is 1. A fourth of 1 is 1/4. Minus 4 is negative 3 3/4. Let's plug in 0. 0 squared is 0 times 1/4 is still 0. Minus 4 is negative 4. And hopefully this symmetry is going to hold. Let's check by plugging in. I'll tell you what, looks like plugging in negative 2 is going to be easier than plugging in negative 1. So let's do that. Negative 2 times negative 2 is 4. 1/4 of 4 is 1. Minus 4 is negative 3. So the symmetry is holding up. That's good. And now we're going to graph this. Two, negative 3. And you notice, have we gotten an x-intercept? Because again, that's the whole point. Let me highlight for you. 0, we had 1/4 x squared minus 4 equals 0. We replaced that 0 with a y. So now we're looking on the graph and trying to find where y is 0. Well, that's on the x-axis. That's where the y is 0. So we haven't quite gotten there. So what I'm going to do is to expand this out one more time. 0, 1, 2, 3, 0, -1, -2, -3. Let's plug in 3 and see if that's going to do it. 3 squared is 9. 1/4 of 9 is 9/4. 9/4 minus 4, we're going to put that over 1. Multiply by 4 over 4 to get a common denominator. -16 plus 9 is going to be -7. So -7/4 is -1 3/4. And of course, we have already established that the symmetry is there, that our vertex is correct. So 1, 2, 3, -1 3/4. Again, I can count to my line of symmetry. 1, 2, 3, 1, 2, 3. So we still haven't made it to the x-axis. So we're going to go one more, 4 and -4. Let's plug that in and see how it goes. 4 squared is 16. 16, 1/4 of 16 is 4. Minus 4 is 0. And that is great. As soon as we see that the y is 0, that's what we've been after this whole time. So 1, 2, 3, 4, 0. -1, 2, 3, 4, 0. That's the x-intercepts. Those are the x-intercepts that I was looking for. So x equals positive or -4. And that does confirm what we had seen earlier. Okay, now the game changes just a little bit. We don't have the math skills yet to be able to solve this algebraically. So we have to solve graphically. Now, of course, if you have a graphing calculator, you could put that straight in and find your x-intercepts. We're going to do it the old-fashioned way. Solving this graphically, we want to see x equals, first we have to replace this 0 with a y, and we'll do that. So instead of 0, we have a y equals x squared minus 4x minus 5. We're going to graph it, try to find where y equals 0. That's going to be my goal. And remember, x equals the opposite of b over 2a. So opposite of -4 is +4. 2 times 1 is 2. X equals 2. So my quadratic equation, my parabola, is going to be centered at the vertex. The x-coordinate of that vertex is 2. Now I'm going to go up 1, up 2, down 1, down 2, from that point, not necessarily from 0. And we're going to work it out. Y equals something squared minus 4 times something minus 5. We'll use this space over here for the moment. Y equals x squared minus 4 times x minus 5. Let's plug in 4. See what happens. 4 squared is 16. 4 times 4 is 16. 16 minus 16 is 0. Minus 5 is -5. Let's see, plug in a 3. 3 squared is 9. 4 times 3, 12. 9 minus 12, negative 3. Minus 5 is negative 8. Let's plug in 2. 2 squared is 4. 4 times 2, 8. Minus 5. 4 minus 8 is negative 4. Minus 5 is negative 9. All right. Now, what should happen is we should get some symmetry here. Now, the easiest one to check for symmetry is going to be the 0, so I'm just going to go ahead and plug that in. 0 squared is 0, minus 4 times 0 is 0, minus 5 is negative 5. So the symmetry is working, so I can safely say that this is going to be negative 8. Now, if I graph this, that's going to be my line of symmetry. And 3, negative 8 should be the same distance to that line and on the other side. 4, negative 5. 2 units there, 2 units on the other side. Now you notice we haven't gotten to the x-axis. That's the whole point. We want to know where, since we replaced 0 with a y, where does y equal 0? That's on the x-axis. Now we haven't gotten there yet. And even though we're solving graphically, we don't want to guess. We want to be very sure. We're almost solving using a table of values because we want to know precisely when y is 0. So let's go up again to 5, down to negative 1. Let's plug in that 5. 5 squared is 25, minus 4 times 5, 20. 25 minus 20 is 5, minus 5 is 0. And that is good news. That's exactly what I wanted to happen. Because, notice that y is 0. Well, here's where y is 0. It happens at 2 places. It happens at x equals 5 or x equals negative 1. Now, it says to check algebraically. How can we do that? Well, we're just going to take the 5 and plug it into this. X squared minus 4x minus 5 equals 0. Take the 5, and we're just going to stick it in. Replace the value of the variable. And we're to see, does this work? 5 squared is 25. 25 minus 20 minus 5. 25 minus 20 is 5. 5 minus 5 is 0. So yes, that works. And there's also the possibility of negative 1. Let's make sure that that works as well. Negative 1 times negative 1 is positive 1. Negative 4 times negative 1 is positive 4. 1 plus 4 is 5. 5 minus 5, 0. And that works as well. Okay, one more here. And wouldn't be a bad idea for you to go ahead and pause the video and see if you can do it on your own. Let's see how you do. First of all, I want to solve it graphically. A part of that is that I'm going to have to try to get a 0 Notice that in the last example, we had 0 already set up for us. Here, we're going to have to do a little bit of work. We're going to have to add 8 to both sides so that we get x squared plus 6x plus 8 equals 0. Now, we have 0. We want to replace that with y. So y equals x squared plus 6x plus 8. We're going to look for our vertex. X equals opposite of b over 2a. B is 6, A is positive 1. So opposite of 6 over 2 times 1. X equals opposite of 6 divided by 2, which is negative 3. So my table of values is going to be centered at the vertex, whose x-coordinate is negative 3. I'm going to go up 1, up 2 from that x-coordinate, down 1, down 2 from that x-coordinate. Let's plug it in. Y equals x squared plus 6 times x plus 8. Let's plug in the negative 3 to begin with. Negative 3 times negative 3, again, we had to put these in parentheses, is positive 9. 6 times negative 3, negative 18. And we're just going to work this out. Let's plug in negative 2. Again, we're just going to work it out. Now notice, I wanted 0. Y is 0. You notice, y is 0 here. So that's fantastic. We've already found one. Let's jump down here to the negative 4 and see if that also gives me a 0, just to confirm that this symmetry is correct. See if we've made a mistake. So equals 0. So that's fantastic. What that means is that basically we've already solved this. We know that x equals negative 2 or negative 4. And we just need to confirm it by graphing and showing that we did do this graphically. So negative 2, 0, negative 3, negative 1, negative 4, 0. And of course, it's going to give me a U shape. We do want to check this algebraically and just make sure. Use multiple representations, tabular, graphic, and algebraic. So we're going to open this up. X squared plus 6x equals negative 8. First, we'll try negative 2. And put a little question mark. We're not sure. We're testing. It appears that works just fine. So this one's good. Let's check the negative 4. Question mark. We're not sure. And that works out well. We've checked both of these, and these do work. Well, that will do it for today. Thank you so much for listening to Crazy Math Productions.